Hello and welcome to day 6 of this bridge course, class 9 to 10th. And in today's video, in today's session, we will be talking about quadrilaterals. What is a quadrilateral? I'm sure you must have heard the term before. A quadrilateral is a polygon with 4 sides, 4 angles, and 4 vertices. So what does that mean? 4 sides: first side, second side, third side, and fourth side. So the figure over here that I have drawn is a quadrilateral. It has 4 sides. It has 4 angles: first angle, second angle, third angle, and fourth angle. So it has 4 angles and it has 4 vertices. By the way, vertex is the singular and vertices is the plural. This is one vertex. This is another vertex, and another vertex. In all, there are 4 vertices for a quadrilateral. Okay, so a quadrilateral is just a 4 sided figure, but there are a number of other shapes which also come under the family of quadrilaterals. All these shapes are all quadrilaterals. Each of them is a quadrilateral because they all have 4 sides, they have 4 angles, and 4 vertices. Take a parallelogram. Parallelogram has 4 sides. Trapezium has 4 sides. Rhombus has 4 sides. A rectangle also has 4 sides, and so does a square. Similarly, they also have 4 angles, and they all have 4 vertices or 4 corners. So in this video, we will not be talking too much about all the quadrilaterals, but we will be focusing our attention mostly on the parallelogram. What is a parallelogram? So I will just clear up this space, and we can talk about that. Okay, now, what is a parallelogram? So there are many definitions, many theorems that provide us more information of what a parallelogram is or what are the properties of a parallelogram. We are going to go through that one by one. So this is the first one. A parallelogram has 2 pairs of sides that are parallel to each other. What does that mean? 2 pairs, 1 pair equals 2. So 2 pairs of sides that are parallel to each other. So you have a diagram that I've drawn which looks like a parallelogram. So when you say 2 sides parallel to each other, this side and this side are parallel to each other, right? And then there are 2 pairs of sides like that. So CD and AB are 1 pair. Similarly, this AD and BC are another pair. So according to the first criterion, a parallelogram has 2 pairs of sides that are parallel to each other. This is condition number 1. Okay, so now let us look at condition number 2. Okay, so we come to condition number 2 that defines what is a parallelogram. Condition number 2 says a diagonal of a parallelogram. This is a diagonal of a parallelogram. The diagonal of a parallelogram divides it into 2 congruent triangles. So this is the DB is a diagonal of the parallelogram. It divides the parallelogram into 2 triangles, and they are just not plain triangles, they are congruent triangles. What does the word congruent mean? Same shape and same size. If 2 objects or 2 shapes are congruent, that means they have the same shape and the same size. So according to this diagram here, or according to condition number 2, this diagonal BD divides this parallelogram into 2 triangles, and these 2 triangles are congruent. They have the same size exactly and the same shape. If you cut it like this, I mean, you draw it on a piece of paper and you cut it like this, you fold it, they will sit exactly on top of each other. That is what is meant by congruent. Okay, this is condition number 2. Now, let us go to condition number 3. Okay, condition number 3. In a parallelogram, opposite sides are equal. So look at the figure on the right. This is a parallelogram. Opposite sides, AB and CD are opposite. So AB must be equal to CD. Similarly, AD and BC are opposites. So AD must be equal to BC. So the third condition of a parallelogram says opposite sides are equal. So the converse of that is also true. So a parallelogram is a quadrilateral. So if you find a quadrilateral in which each pair of sides are equal, then it is a parallelogram. So what that says is, I'm going to draw here. Let us say this is a quadrilateral. Okay, I have to remove the automatic shape. So let me remove that and then try it again. So let us say this is a quadrilateral. In this quadrilateral, if these two sides and these two sides are equal and these two sides are equal, then this quadrilateral must be a parallelogram. That's what must be a parallelogram. That is what this condition says. Two opposite sides are equal, and if a quadrilateral has two opposite sides equal, it must be a parallelogram. This is condition number 3. Okay, let us go to condition number 4 or theorem number 4 about parallelograms. Theorem number 4 says the diagonals of a parallelogram bisect each other. What does bisect mean? So let us say I'm going to draw this diagonal. Okay, see, BD is a diagonal. A diagonal is a line that joins opposite points, be it opposite vertices or vertices. So BD is a diagonal, CA is a diagonal. So BD, when it cuts AC, that means it cuts AC in a way that if we have a point O, AO equals CO. AO equals CO. Let me clear this up. AO equals CO because BD cuts AC. Similarly, AC cuts BD in such a way that OD equals OB. So this is equal to this. So the diagonals of a parallelogram bisect each other. Bisect means cut equally into two pieces. So the converse of that theorem is also true. What does that mean? If you have a quadrilateral, and in that quadrilateral you see that the diagonals of that quadrilateral bisect each other, then it must be a parallelogram. So that quadrilateral must be a parallelogram. That is what the converse of theorem 4 says. Okay, so this is condition number 4 that describes what a parallelogram is. Now we will go to another part of quadrilaterals called a midpoint theorem. The midpoint theorem is actually comes under the chapter quadrilaterals, but it has to do mostly with triangles. So these are the 4 conditions. These are the 4 theorems. Actually, there are 8 theorems. I just merged them into 4 because every 2 of them are similar. These are the 4 conditions or theorems that define what a parallelogram is. And any questions, I request you to watch the last few minutes again. And if you still have any doubts, please post comments on the video. So now, as final part of this video, we will talk about the midpoint theorem. What is the midpoint theorem? The midpoint theorem has something to do with triangles, even though it is under the chapter quadrilaterals, but it is about triangles. So I've got 2 triangles here, and let me explain by reading the midpoint theorem what we are talking about here. So the theorem says the line segment joining the midpoints of 2 sides of a triangle. So this is, if you take the first figure, this is a line segment that is joining the midpoints. So D is the midpoint of AC, E is the midpoint of BC. So this line segment that is joining the midpoints, is parallel to the third side. So this and this are parallel. So again, to repeat, if DE is a line segment that is joining the midpoint of AC and the midpoint of PC, then DE is parallel to AB. That is what the theorem says. So the converse of the theorem says something very similar, but the other way around. So what the converse says is the line drawn through the midpoint of one side. Okay, AC is one side and D is the midpoint of AC. So if D is the midpoint of AC, and if you draw a line DE, which is parallel to AB, if you draw a line DE which is parallel to AB, then this line DE intersects BC in a way that CE equals BE. So this is the midpoint, and this line is parallel to this line. Then um, PE is equal to BE. So this line is bisected, and that is what the converse of the midpoint theorem says. So with this, we conclude this session, this video, and please feel free to add your comments, and I will meet you in the next video tomorrow at 5 p.m.